So welcome back to the Python programming series. In this video, we'll be doing something a little different. So we won't be working on any particular aspects of Python itself. However, we're going to be working with a module, a pretty well-known module for 2D graphics in Python. So it's called Pygame, and it's a generally powerful and versatile module. So it can be used to create drawings, games, animations, whatever, anything of that nature. And it's beginner to intermediate friendly. It's not extremely basic, but it's not extremely complex either. It's just in the middle, And just some quick notes and terminology in Pygame is that all graphics areas. So in Pygame, we actually create separate windows that we work in. It's not going to be in the console, obviously, as we've been working in before. All the graphics areas we actually draw in, animate, and play our games in, or whatever we're creating. Anything GUI like, so graphical user interfaces. They're all referred to as surfaces in Pygame, at least. And colors are RGB values. So if you're not familiar with RGB values, they're mixtures of red, green, and blue. And essentially all colors you see on a computer screen or any sort of digital screen, they're all combinations of red, green, and blue values, RGB. And it's not red, yellow, blue, as with the primary colors in real life, because computers, in basic terms, computers emit their own light, and so obviously they have to use green instead of yellow. Not going to get too specific on that, but the point is computers use mixtures of red, green, and blue to represent all colors and actually display colors on their screens. And a quick note about the coordinate system in Pygame. This is going to be more specific to what working with Pygame in general, but especially specific to what we're going to be doing in this video, which is just focusing on drawing in Pygame. So the coordinate system is different from the typical Cartesian plane we deal with in mathematics. So in mathematics, just some general knowledge you probably know, is that the origin is when we're talking about in reference to the first quadrant, the origin is typically the bottom left in the typical Cartesian plane, However, in graphics in general, or Pygame more specifically, more so, the origin is not the bottom left, it's instead the top left of the screen. So the x-axis is acts just as it does on the coordinate plane. It's horizontal, right is positive and left is negative. But in Pygame, the y-axis is essentially flipped over. And so what I mean by that is below the top left, so essentially the entire left side of whatever screen we deal with in Pygame, the entire left side is positive y. So, and then everything above, like imaginarily everything above that origin at the top left is going to be negative y. So if we look at the top left outside of our Pygame screen or window, that'll actually be negative y, negative x, negative y. Sorry. So if what I said is confusing, I don't really have any graphical way to display that right now, but I think that explanation should pretty much cover it. The main thing you should know about the coordinate system in Pygame is just that the origin is the top left, positive y is the left side of whatever Pygame window we're dealing with. Essentially, the y-axis has just been reflected over the x-axis. That's essentially it. So when we're dealing with Pygame, it's not actually it's not anything you can really just straight import without pip installing it. So I'm not gonna actually do a tutorial on the pip install of Pygame. There are many videos on YouTube, and I don't want to recreate anything. So you can look up a different video just for the pip install of Pygame. It's pretty simple, pretty easy. Sometimes it causes problems, but I suggest videos like ones from Tech with Tim, for example. He has good videos. Yeah, that's my personal recommendation. But anyways, once you do have Pygame pip installed, meaning you have it on your computer, and it's set up with whatever IDE you're using in the environment of it, we just want to import it. And I know that was a pretty general explanation, but I'm not trying to go very specifically into the installation. I'm just trying to get right into how to use Pygame and how to deal with it. So we want to import Pygame once you have pip installed and everything. And then, in general, we want to start creating our window, our primary surface. Usually in Pygame, we're really just dealing with one surface, usually. And so let's define the width and height of it. Let's say 500. I like that size. And just a quick side note that constants in Pygame, so values that don't change, are typically in all capital letters. So the variable names, like width and height of the screen, aren't going to change. And the window itself, and these are just some method names you probably, some method and function names you probably just, there's no really way of just remembering them. You just do have to commit them to memory. So pygame.display.set_mode, that'll take an positional argument, a two-value tuple, so width and height of the screen, or whatever surface we're creating here, which is the primary screen. It's going to be width by height. And the measurement we're using for this is pixels. So when I say width by height, I mean width pixels by height pixels. So 500 pixels by 500 pixels. And later on, we'll also use, well, not necessarily right now. Sorry about that. Don't worry about the FPS. Now, again, the RGB values, we also want to just define some general colors we might use more so in our program, some common colors. Maybe not very specific ones, but like definitely red, green, blue, white, black, maybe gray. So red would be 255, 0, 0. And again, how the RGB values work is that each of the three values in this three-value tuple in the RGB combination, each one can go from 0 to 255 inclusive. If it goes out of that range, it's not really an RGB value. Don't ask me why it goes up to 255. I'm not going to explain that. So green would be 0, and we're just defining purity. Like the pure versions of all these colors. White is just a maximum of all the colors, and black, likewise, is just nothing of any color. None of any color. So now that we have the window kind of up and running, and we have our colors defined, we should have a window up and running, right? Intuitively, right? Let's see what happens. Let me just save this. So you see that we just got a Pygame window right there for a brief moment. And that's expected. That's expected. We'll fix that in just a sec. So essentially, when we're talking about games, we're not creating a game right now. However, when we're talking about games, there's usually like a main game loop keeping all the events recurring. But when we're just talking about a drawing, not an animation or anything either, just a drawing that we want to do, we typically don't even need to use a loop. It's generally just we draw whatever we want, and then we have to update the screen, okay? That is important. So how Pygame works is essentially you're drawing something off screen. Essentially, you're drawing something off screen, and then to actually transfer it to this to a specific surface, you do have to do pygame.display.update or .flip, and I'll show that in just a sec. So pygame.display.flip or pygame.display.update. These are effectively the same exact thing, but the minute difference is that flip will flip the entire screen, no matter if anything changed or what, and update will only update specific portions of the screen that have actually really changed. Other ones will stay just for the sake of like efficient resource use. In basic terms, that's the difference. I just recommend using flip, or I used to use update, but it doesn't really matter to me. Anyways, at the end of our program, after we're done drawing everything, when we're just drawing stuff, we want that to be after we draw everything. So there's some specific functions, some specific methods we can use to draw certain shapes and everything on a specific surface. Okay, so first one, before you actually show them, there's one to draw a rectangle, a circle, an ellipse, an arc, polygon, and those are the main ones. That's pretty much all you need. So first one, Pygame and they're all under the sorry, not Pygame.display.draw. They're all under the Pygame.draw kind of submodule, whatever you want to call it. I don't really know if I can refer to it as a class. Can I? I'm not too sure. Anyways, it's under the Pygame. It's under Pygame.draw. So to draw a rectangle, we do Pygame.draw.rect, and then it takes in a couple of arguments. First one being the surface. So again, surface. The only one we're dealing with is just our primary window. The one we're going to the second positional argument is going to be the color. Let's say red. Okay, we've defined red. And then in the third argument is just a tuple of 4 values, 4-value tuple. Excuse me, I'm coughing a lot. So a 4-value tuple is going to be the x and y position of the rectangle, and then the width and height of it, all respectively. Now keep in mind, when we're drawing stuff, when we're really just generating stuff or drawing stuff, especially in Pygame, it's all going to be in reference to the top left of whatever we're drawing or generating or whatever. So when we're drawing a rectangle, whatever x and y coordinates we put in this 4-value tuple, the first 2 values of it, that's actually going to be specifying the top left of that rectangle, not the middle, not the bottom right, top right or whatever. It's going to be the top left. And that just makes it easier for the computer to work with these numbers and stuff. Not necessarily, it's just more intuitive. Anyways, it's going to be referencing the top left. So let's say we want like somewhere, like we want the top left in the middle, not width over height, width over 2, height over 2. So that'll put the rectangle's top left in the middle, not the rectangle itself in the middle, but its top left. And let's say it's going to be 64 by like 128. So let's run this. Let's see what happens. You see, we briefly got something right there. We saw the rectangle just very briefly. Now, the reason the screen just pops up and goes away is because it's just exiting the program right away. I mean, it does all this initialization we did up here. It gets through to drawing the rectangle. Then it actually updates the screen or flips the screen so we can actually see the rectangle, but it doesn't wait or loop again or do anything. And so it just exits the program. So what we want to do after we actually update or flip the screen is wait a little bit. Okay. So what Pygame.time.wait will do, so Pygame.time is also very useful. The wait method or function under it takes in a 1 positional argument, and that is the number of milliseconds to wait. So 5,000 milliseconds here, meaning 5 seconds. So after we draw it and then after we draw the rectangle and then update or flip the screen, it's going to wait 5 seconds before actually exiting. Okay. So you can see we drew a rectangle right there. Wait 5 seconds and it's gone. Now, best practice is to also kind of quit or exit the Pygame module, just so that it's not left open and essentially not corrupted in any way. Just to really ensure, it's best to put Pygame.quit essentially when the program is done using Pygame completely. So yeah. Now, if we wanted to draw a circle, it's essentially the same thing. All of the draw functions follow essentially the same format of positional arguments. It's always like the surface first, color. Let's say green, and then we also we want to put that at like 100, and then what the circle will actually do is just a tuple of two arguments right there. The third argument is just a tuple of two values. So those two values are the x and y respectively of the center of the circle. So this is going to be centered at 100, and we have to specify the radius outside. And the fourth positional argument, let's say it's going to be of radius 15. That should be fine. So you see we got a green circle up here as well. And that's essentially it. Another Pygame some function is you can say ellipse. Okay, this one's a little wonky, but it's pretty similar to the rectangle drawing. So again, surface and color, and then you'll have the top left of the ellipse specified. Now you might be confused as to what that means. I mean, when I say the top left, I mean the top left of the smallest rectangle that would enclose the ellipse, enclose or surround the ellipse. So let's put that at like 200, 100. Why not? And instead of making it green, actually, let's make it blue. And in the tuple, it's actually 4 values as well. So we also want to specify the width and height, so the dimensions of the rectangle that would surround this ellipse. So let's say it would be 100 by, I don't know, it's 100 by 300. And that'll make an ellipse. Let's see this. You see we got a huge blue ellipse there. Now, yeah, that's essentially all there is to an ellipse. And there is one other thing I do want to mention after all of this. But let's look at drawing an arc now. Again, surface, color, let's say white. And what we actually want to do here is specify the top left of the rectangle that would enclose it. So let's say, I don't know, 100, 300. And we would specify the dimensions of the smallest rectangle that would directly enclose this arc as well. Let's say 100 by 100. Well, no, that would be too much. Yeah, why not? 100 by 100. And then it takes two more required positional arguments. Those being the start kind of angle measured in radians, and then the end angle measured in radians. So it's kind of hard to explain what I mean by that, but let's see the example. So to easily convert from angles to radians in Python, you can just use math.radians, and then in that function you specify the angles you want converted to radians. But in general, just in math, you just want to multiply the angle, whatever you have, and then to convert it to radians, multiply it by pi over 180. But let's use math.radians, why not? It's there for us. So import math and use math.radians, and then whatever angle, let's say 45, okay? It starts at 45 degrees and starts drawing an arc all the way around to, and keep in mind that this is counterclockwise, all the way around to the, what should the angle be? 315 degrees. So we will have like a 90-degree angle kind of at a 45-degree angle, if that makes sense, at the right side of the circle. Essentially, yeah, it'll be a circle with a quarter, with pretty much right quarter cut out of it. You'll see what I mean. So let's do this, and boom, you see that this kind of white C here. Now there are some optional arguments you can pass in, optional parameters, optional arguments you can pass in to all of these draw functions. So for the rect, circle, and ellipse, the very last argument is optional, and that's just if you don't want the shape filled in, but instead the outline to be a specific number of pixels wide. So let's say 10. Let's say 10 here as well, and 10 here as well. Just why not? So you'll see all of these are actually 10 wide each now, on the circle, ellipse, and rectangle. Now the arc has a similar optional argument, optional parameter. And keep in mind when we specify this optional width parameter in terms of pixels, the default one we already saw is 1 pixel wide, but we can specify it to be like if we said 100 by 100 here, then it should be 50. If we just want to fully fill it in, then it's obviously just going to be half of the half of the similar dimensions of the rectangle that surrounds it, if they're the same. So you'll see what I mean. It looks like a circle with a piece cut out of it. See, there we go. Now here's something worthwhile mentioning about filling in the arcs like this. It's not ideal to fill them in like that because as you probably saw there, the fill in essentially or width of the arc line is 50, but that creates like some small like black splotches all throughout, and that doesn't really look nice. But the point is, yeah, you can also specify the width of the arc line, just as you can with these other draw functions. So there is one other called Pygame.draw.polygon. And as you might have, as you probably guessed, it draws a polygon. But this is just a slightly different. Let's make this cyan. So cyan is actually just going to be full red, full blue. It looks nice. What this is actually going to do is take the third kind of positional argument will be a list of tuples, and each of those tuples being xy ordered pairs, in order for the line of drawing the polygon to go from in order, in the stated order. So let's say it goes from 0, 0 to 10, 10, 20, and to 100, 100, 100, 50. And as with the other, likewise with the other ones, like the other draw functions also have, it has the optional argument for the width of the drawing itself in pixels. Let's say 5. It's just a nice width, and you'll see it draws it with the width of 5. The cyan streak here. It's actually a polygon. It's just really kind of everything's kind of close together. Let's say 150 or something. And you can see the polygon being a polygon more clearly. Oh wait, sorry, not the last one. Just switching it around so it's at, oh my god, these points are way too close in terms of being in a straight line. Oh my god. Let's say 50, 20. Just trying to really show the polygon being drawn itself. Yeah, there we go. It's just a triangle because we specified 3 points. So it goes in the order specified all the way to the end one, and then connects the end ordered pair to the first one mentioned in the list. So that's all there is to really Pygame drawing. That's the main stuff. In games we'll develop later on in later videos and stuff, we'll definitely use Pygame, the rect drawing, circle drawing maybe, but Ellipse, Arc, and Polygon less likely, just because I don't find much use for them in games, or at least games that I like to create. So, but essentially that's all there really is to the basics of Pygame drawing and some basic Pygame knowledge. So hopefully you enjoyed this video, found it helpful, and I'll see you in the next video, which will probably be a Pygame video as well.